Hi everyone, I'm Sandeep Giri. I'm from CloudXlab. I'm trying to create a video of a demonstration of how to run MapReduce program end to end. All right. So CloudXlab provides you an online lab for big data, machine learning, deep learning, and other artificial intelligence technologies. All right. So you do not have to install your cluster or you do not have to install any other machinery. Most of it is available at CloudXlab. Okay. So here, what we are trying to do is we are trying to set up a dev environment because environment need to be set up on a developer's machine. It cannot be provided on CloudXlab, right? So in case we provide the developer environment on the cloud, it'll be very inefficient and the users will not like it. All right. So as part of this, what we are going to do is we are going to start with an empty Windows machine. Right now, this is an empty Windows machine, which I have taken from a hosting provider called Paperspace. And there, I'm going to set up end to end. All right. And so you can, this is the developer's machine. Okay. This is the developer's machine. All right. So let me get started. Okay, so first of all, the most important thing is to log in into CloudXlab. Okay, so if you do not have Chrome, please install Chrome because that's a browser. Most of the services are compatible as of today. Okay, so first of all, let's try to um, log in into CloudXlab. Okay, so .com. Okay, all right. So the general workflow is going to be like this. Let me open Notepad right now. Okay, so accessories, and there is Notepad. All right, so here you go. So the typical workflow that we are going to do is, okay, all right. First of all, we are going to install a good text editor, okay, because this Notepad is not good enough, and then we log in into CloudXlab. Okay, so we're going to install a good text editor such as Sublime. Okay, all right, I'm going to say Windows 64-bit. Most of the machines today have 64-bit architecture, so use that one. All right, so let me just start with Sublime. Now you could see that while I was trying to write notes, the formatting was bad. Therefore, I had to switch to the new editor instead of Notepad. You can see that the tabs or the new line of Unix is gone in my notes. Similar things will happen with other parts of the code as well if you are trying to use Notepad. All right. So it's generally suggested to use some other text editor. All right. So you can see the Sublime is installed. Now let me again show you the steps which we are going to take. All right. I've just copy pasted my notes here. Good. So first of all, we are going to go with login into CloudXlab. That's a general step, and then we are going to achieve this. We are going to use a source code repository, okay? And we're going to check out the code on Linux machines and then compile there and run it, okay? So for this, first of all, we will log in into CloudXlab, then install a good text editor, which is already done, so we'll mark it hash, then sign up with GitHub, and then clone our repository, and so on. All right, let's start. So we have downloaded Sublime, so we can close this window. Now, this is the CloudXlab website. You can log in into it. You can use your Google account. If you have not signed up, you can sign up with CloudXlab. So here I'm going to use my personal ID. Okay. And all right. So it's kind of going to give me an OTP because I'm trying to log in from some machine which is very remote. And okay. So it gave me a prompt on my personal login, a personal phone screen, and I approved it. Okay, good. So now when you log in, you see these all the details, right? You see the default videos on how to do this, how to do that. Then you have lab credentials, and you have MySQL credentials, and you have private to public IP addresses mapping. And then you have a support tab. Support tab, you generally have the discussion forum, and then you can also email us at this. All right. Now let's get back to the lab credentials. Let's keep it handy and open a web console. All right. A web console is nothing but an alternative to using. I have zoomed it out a little more. Okay. So all right. I think this is okay. Good. Now let me go back here and take my login. Okay. All right. So I've just copy pasted my login and I've copy pasted my password. All right. So this is the Linux console that we are going to use. This is on CloudXlab. Okay. Typically in a real development environment, you are given a server which is a part of Linux cluster, or you're given a machine which is either edge node or one of the nodes which is participating in Hadoop. So e.CloudXlab is one of the machines which is participating in Hadoop, as in it has data node, it has name node, and other utilities. All right. So let's leave it here. Now we are going to go back to the rest of the process. Okay, let's get back to the rest of the process. And what was the rest of the process? Now, once we have logged into CloudXlab, this is done. Okay, and now let's sign up with GitHub. What is GitHub? Or before jumping into GitHub, let me talk about Git. Git is a version control system. As of today, Git has replaced most of the other version control systems, such as SVN, such as Perforce, and Git is being used across the globe at the companies like Google, Amazon, and everywhere to manage the source code. In case you're wondering what does it mean by managing the source code, in a complex software development, what you need is you need a track of each and every change that occurs to the software, right? And it has to be collaborative. So for that, Git is a great tool. If you are not handy with Git, I would recommend that you go through Git. Right? Git is open source, free, and easily available, and there are many documents available to learn Git. Also, Git is installed on CloudXlab, so you can experiment with Git. So Git is a client as well as a way to manage the repository, right? And there are something called hosted repositories or remote repositories such as GitHub. All right, GitHub has both kind of repositories. One is called private and other is called public. Public is free and private is paid. Okay, the alternative to GitHub is GitLab in case you are trying to host a private project which you do not want to make it open to the public. As well as in your organization, the chances are you will have your own GitHub repository. All right. So let's sign up with GitHub. And for me, since I've already signed up, I have my login and password created. You can create your own login password and then log in. Okay. So let's open GitHub. Go to the browser and search for say github.com. You can see. All right. This is this is where you can sign up. You can give your username, email address, and create password. But for me, because I have already created my account, I'm going to use an account Sandeep CXL. All right, I have logged in into my account. Okay, and as part of this account, we already have some repositories. I'm going to delete my older repository just to demonstrate to you the entire thing from the beginning. Okay, for now I'm just deleting this repository. How do I delete it? Okay, so probably I can go to settings and remove it. All right. Okay, so okay, let me just see if I can delete it some way. Okay, let me go back. All right, let me just delete this repository. Okay. All right, so let's start from the beginning. So right now, what we have done is we have signed into github.com, and there we are going to open the repository which is provided here. Okay. right? So we have created sample code or example code at this location in GitHub. Okay, so we are going to open this repository and then take a look at the code quickly. So this is basically a code this is basically a repository which contains most of the example related to Scala, Spark, Hadoop examples. This is the one which contains the MapReduce examples. Okay, this is the one that contains MapReduce examples, and we're going to, though we are going to check out the entire repository, we're going to interact with mostly this folder. Okay, so let's move on. Now, right now, this is a repository at cloudxlab/bigdata, right? Now, and you can see in the URL also. Now, what we are going to do is we are going to click on fork. Okay, we are going to make a copy of this repository. Okay, similarly, you are also going to do the same thing. Okay, which means that we'll have a copy of this one, and we'll make changes to this repository as per our wish without impacting this repository. Okay, in case in future you want to contribute back your code to the parent repository, that is very much possible. Similarly, you can further merge new changes from this parent repository into your repository. Okay, so that's the flexibility, that is the flexibility which Git or any other source code management tool brings in. You can do all kinds of merges. Okay, so let's create a fork. Forking is not same as copying the code. It keeps a track of the parent repository. You can see that this is your repository after forking, and this is the parent repository. Okay, since I have logged in from user accounts and the CXL, which I've created for this session, and right, just like another user. Okay, so what you have is this repository which contains most of the code. All right, next thing we are going to do is we are going to log into CloudXlab and clone this repository. Okay, so let's take this URL, copy it to the clipboard, go to CloudXlab. Okay, and since I already have a repository called bigdata, I can delete that one and use this repository instead. Okay, so how would I use? I'll say git clone. So git is a tool, a client, which is pulling which is going to pull the data from this repository. Good. So it has cloned all the objects. Now we go to this folder. It says that cloning into this folder. You see that? That means there is a folder called big data that's going to be created. And you can see that before cloning, we had deleted this folder because I had done it earlier. So I had the same name, a folder with the same name. Okay. You can see that the big data folder has been recreated. And if I say ls, okay, it is showing that these folders have been created, right? Which are same as these folders. You can see that, just that it is not showing you .gitignore file. Okay, why? Because if those are hidden, to see that you can say ls -a. You can see, so all these folders are being displayed correctly. All right, next is, okay, so this is our Java code. All right, you can take a look at the actual code here. This one contains all examples of MapReduce and Hive. Okay, so this is the one which we are going to run. All right, so this is the driver. What you see here is the driver, and this driver has a main class. Okay, and This is the entry point for our MapReduce. Okay, this is the main method, which is the entry point. Okay, now let's try to after cloning, let's try to compile it. How do we compile it? Okay, the instructions are also written on this page here. Okay, if you go here, I'll show you the instructions. Okay, after cloning, you go into this folder and then you run jar. Okay, so let's go to HDP examples. You can press tab to autocomplete, and then you go to Java, right? Using the cd command, we change the directory to that particular folder. And once we are in that folder, we can see that there is a file called build.xml. This is the file that is going to be used by Ant. Ant is a program which is used for building complex softwares. And in production environment, Ant is the one which is going to be used for compilation. All right. Sometimes you must have used make. If you are programming in C or C++, you might have used make. And in the modern world, the Ant has been replaced with Maven. Maven. Okay. So earlier it used to be make, then Ant, then Maven, and now there is SPT. All right. So for now, we're going to use Ant. Ant basically will try to compile the software, right? SRC contains the source code, and lib contains the libraries required for compilation. Okay, so you can go to the GitHub repository and check the lib folder as well as check the SRC folder here on the GitHub repository. You can take a look into these folders and understand the code. Now, for now, let's try to use jar. Okay, what is jar? Jar is the target that we are trying to compile, and we have defined the meaning of jar inside build.xml. Okay, build.xml contains entire instructions. Okay, if you want to take a look at build.xml, you can take a look at it here. Okay, what you see is here we have defined the entire process of compilation. For example, compile means these, where you creating a directory, calling the Java compiler, and here when we say target name jar, we are essentially creating a directory and then we are packaging entire thing in jar. You see it here? Okay. And also note that it depends upon compile, which means that when you call jar, it's going to call compile first, this one. And then once that is done, then it will bundle everything. Okay. So there is a huge usefulness of these build tools in the sense that they provide a way to define dependencies between multiple tasks that you are going to do. For example, when you are testing also needs compilation. Similarly, when you are preparing jar or when you are trying to prepare documentation, that also requires preparation and compilation. Okay, so those kind of dependencies between various tasks are maintained by the way of build.xml, and they are executed using Ant. So you can see that it has created directory, then it's compiling. You can see it is compiling, and afterwards, once it's compiled, it has built the jar. What is jar? Jar is a bundle. .jar file is a bundle like zip files containing all the compiled binaries, right? Java bytecodes are going to be bundled in this along with other property files, libraries, whatever is required in the production. Okay, so this is your artifact. Sometimes we refer it as an artifact. Okay, so the next thing which we are going to do is we are in which folder? We are in Java folder. Okay, next. All right, looks like okay. Next, we are going to call this, either we can use absolute path or we can use this. Okay, to see the exact command, what we are going to do, we can refer here. Okay, we have already written the how to run the command. You see, Hadoop jar, that's the Hadoop's command called jar. Here it was our target called ant jar, and .jar file is the bundle of files. Okay, bundle of files of Java bytecodes. Now Hadoop jar, and then we are passing the we are passing the artifact or the package, and then we are saying that this is our entry point. It is the same entry point which I took you to. It will be inside here. There'll be a folder called word count, and inside that there'll be a file called StubDriver. That file is the Java code containing our entry point for this example. Okay, what it does is it basically computes the word count. Okay, so let me try to run it. So it's basically running this particular jar on a real cluster. Okay, it's running on yarn on a real cluster. Okay, it says that the folder already exists, meaning the output file it's trying to create already exists. Also, please note that if you take a look at the code, if you take a look at the stub driver, it has hard coded the location of input and output file. It has, you can see that here. Yeah, here this is the input path that we have hard coded. Okay, either you can use Hadoop fs-cat command to see the details about it, or you can use you can basically use this kind of model. All right, and so okay, let me come back again. So when you say when you want to see the details about this file, since this file is located in HDFS, and any file that you want to process in Hadoop need to be located in HDFS, and this file this file, either you can view it through Hue file browser of Hue inside CloudXlab, and or you can use Hadoop fs-cat to see the details about it. Okay, let me show you quickly, though it's going to scroll really fast and it wouldn't make much sense to do it. Okay, Hadoop fs-cat, this is our input file. Okay, it's a huge file which contains a lot of text. It's not wise to print the entire text on the console just like this. Okay, so it has scrolled through very quickly, and this is the output folder that's going to be created. Okay, and since we have not started the URL with slash like this one, this is the absolute location. This is a relative location. What does it mean? It is with respect to your home folder in HDFS. In HDFS, your home folder is /user/ your login name. Okay, so we're going to first delete this. Okay, delete the previously created folder. Okay, next is we are going to try running the MapReduce again. Okay, all right, this is the command which we are using. Ideally, we should not be hard coding it. We should be taking these arguments to our program. We should be taking these values as arguments to our program. Okay, all right. In the meantime, we can log into CloudXlab, Hue, Okay. Again, you have to copy paste the login password. Okay. So we do not want to save it since okay. So when you click on file browser, you see HDFS. This is my home folder. For you, this might be empty. Okay. So you go at the top folder at this location, go to data. Okay. And then inside it, I'm trying to locate the input folder that we were using. Okay. For some reason, it got disconnected. Now trying again. So when you, all right. So what you see is this is the folder that we were using for our example, right? Big.txt is the file that we have used here, right? So we went into the same folder using Hive file browser, and we can see the input. All right. So this is the input file, which is same for all. Kind of, it is a central position, central location. Most of our data is located in slash data. Most of our data is located in slash data for Spark, for Hadoop, and for other instructors as well. We have put the data here. Okay. Now let's go back to our home directory. Now, since I have many directories, so the newly created output file of our MapReduce would be the latest one. So we have sorted the data. So we've sorted these files in HDFS using Hive based on the date. Okay, so this is the folder that just got created, and it has this part. Okay, so basically this is the one. This is the result of our example. And what was our example doing? Our example was doing word count, the traditional hello world example of MapReduce. Okay, so this is where the result have occurred. The data is ordered by the word, but it's not ordered by the counts. Okay, if you want to order it by the counts, you might have to write another MapReduce. So we were able to successfully run, compile, run our MapReduce. And for doing that, we cloned the repository. We also learned how does Git function. We just learned the basics of Git in the sense that we cloned using Git. Okay, cloned means the copy of the entire repository comes to you, which you can use. All right. It's important to learn Git because in today's world, nobody's using, nobody's developing without any source code control. Okay, and Git is probably the most widely used as of today. Okay, so that was our introduction to using to to running MapReduce directly via CloudXlab. Okay, sometimes you may want to change something, right? And you do not want to go through the of ordeal of mm, ordeal of installing Eclipse and other things. In those cases, you can simply edit the file here itself. Okay, you can simply go down. Okay, and let's say instead of saving results into this file into Java MRout, let's say we want to save it into Java MRout demo. Okay, so what do we need to do? We just modified the file. Okay, in GitHub, we will have to save it. Okay, we will have to save it. Okay, to save, you need to provide some comments. Okay, saving. All right, let me just provide some meaningful comment. Generally, you provide meaningful comments to your Git commit. What is it that we are trying to do? We are providing a description for our change. If something goes wrong in production, these comments are going to be useful. So let me just write a little bit more description. Um, instead of Java mr out, saving to Java mr out underscore demo. Okay, so I've committed the changes. Now, these changes are there in this repository, but they are not yet reflected in our production. Okay, so I forgot to explain that once we have run MapReduce, it did produce the output file Java mr out, which we saw there was a part -0000, right? Here there was part -r00. Since there was a single reducer, there was a single file here. Okay, and underscore success meant that the MapReduce was successful. Okay, and all of that, if there are multiple reducers that you're using in your MapReduce, there'll be multiple part files. Okay, so also when MapReduce did finish, it displayed the entire details. Okay, and also it gave us the URL. Okay, those who are wondering, you know, where is, let me go down a slightly. Okay, all right, let me go slowly up so that you can see that there are details available. Now this is the URL of the job. Okay, since it has redirected to this URL internally, and this is an internal URL, so always you have to find out a public URL corresponding to it. Ideally, in organizations, this URL is internal, so it's okay to make it public, make it accessible to all, and therefore it doesn't. Therefore, there's no reason. In real environment, you generally do not keep these mappings. Okay, so we are trying to access 173, 172, 31, 13, 173, 31, 13, right? And this is c.cloudxlab. Okay, so we have to provide the public address. Okay, so you can see that there were these many maps, these many reduces, and the compile was successful. Okay, right? So you can see that it has run in 5 seconds. This map took 5 seconds. Shuffle time was 2 seconds, and so on. Okay, all right. And each map task has got the task ID, and each task has got attempt. If it failed running on one machine, it'll try the attempt on another. Then you could have seen multiple attempts here. Okay, if you want to see the logs, you can click on it and take a look at logs. If you are printing something inside your file, you are using, say, printf statements in your program, you will see std out here. All right, and so on. So this is the overview of a job, the log of the job. Okay, so getting back, so we were able to run our first MapReduce successfully. Now we have made a slight change using GitHub repository. Here, what change we have made is we have changed this to Java MRout demo. Okay. Now, how will we take this change to our CloudXlab checkout? Okay. Let's see in which directory are we in. Okay. Let's go up. Okay, again, let's see what is our directory using pwd. Pwd represents present working directory. So here we can say git pull. Git pull will automatically pull the newest change, and it is showing that this change has come in. Okay, so to see the log, we can quickly see that whatever comment we wrote are reflecting here. Okay. All right. So you can see that these are the basic commands: git clone, git log, and git pull. Okay. Now once we have done that, we can now go back to our folder again, to our HDP examples, right? And what was the folder inside it? It was with the name Java. And then once we are in that folder, we can again easily do &jar, and it will pick the newer code and compile it again. Also, please note that in bigger environments, &jar generally picks up only the newer code, right? Here, since it's a single file, the recompilation would happen anyway. Okay. And so what we get is a very fast build instead of recompiling everything. There's a quality of and. Okay, now let's try to execute the same command that we executed again. I'm pressing the up arrow key to go to the history. Okay, you can also press Control R to search in the history. Okay, that's a property of the console or shell. Okay, so it has successfully finished, and if we go slightly up, will it go slightly up? Yeah. Okay, so again, we can take a look at the new log URL in the same way, and also, right? Also, we can take a look at the statistics in the same way, the way we have done it earlier. Okay, now let's go back to the Hive file browser, and click on Home and see if Java MRout underscore demo has been created. Let me sort my files based on the time. Okay, so you can see that Java, this time it has created this folder instead. So whatever changes we made, they did in fact got reflected. So how did we do the changes? We went to GitHub repository, we made the modification, right, by clicking on edit inside the browser, and then committed the code. Then we went to the console, okay, and then pulled the repository since we had already cloned, and then we compiled it again, and then we executed the Hadoop jar, right? So that was a quicker way of doing minor changes. If you have to do bigger changes and you want to really develop a really big software, in those cases, you would want to have a proper developer environment set up on your machine. Okay, so let's try to set up the developer environment on your machine. Okay, so in the next step, what we are going to do is we are going to set up the developer environment on this machine on which we have just installed an editor called Sublime and opened Chrome browser. Okay, so next thing we are going to do is we are going to set up Eclipse, then build jar on your Eclipse, and then copy that to CloudXlab. Okay. And then we are going to attempt this model from Eclipse to GitHub, from GitHub to Linux machine. Okay. So first of all, let's install JDK. JDK means Java Development Toolkit. Okay. So let's install JDK. JDK is not generally installed, so it's better to install the JDK in the beginning itself. And though Java is installed by default, okay, Java is installed in many machines by default, okay, but Java Development Kit is not. So we are going to Oracle, then we clicked on download and we have come here. Now we are on Windows 64, okay, and chances are you are also on Windows 64. Probably it'll be in somewhere in your computer architecture. If you go to computer management and properties, you will find that. Now it is asking probably to accept the license. Yes. Okay. And click on accept. Okay. Now we're going to download this exe. It's the installer for Java. I've clicked on the exe so that the installer will launch immediately after finishing download. Okay. Let it finish downloading. It's going pretty fast. All right, run the downloaded installer. So what we understood was to make changes to the code, you don't really need a development environment the way we did just now. But if you want to develop bigger software, you would like to have your own environment. Okay, this is something even if we provide it on the cloud, you wouldn't really enjoy it. Okay, so let's just go through the installer UI and whatever it prompts to. All right. Okay. All right. So we have installed JDK. Let's see what happens further. Now, the next step, even though the exercise is about Eclipse, right? But we are going to install Scala IDE because in future tutorials, when we are talking about Spark, we would need the Scala IDE, right? Because Scala is generally the preferred language. And with Scala, since Scala runs very well on top of Java, Scala essentially compiles to the same bytecode as Java. Therefore, the end result of Scala is actually same as Java. Therefore, there is a slight difference only with respect to coding in Scala, while the rest of the machinery remains same. And Scala IDE is nothing but Eclipse plus Scala plugin. Eclipse provides many plugins, and Scala plugin is just one of those. So Scala IDE is a bundle of Eclipse with Java syntax highlighter and Java properties plus Scala compiler. Okay, so we are going to use Scala IDE. Okay, and after downloading, we are going to use GitHub Desktop that we'll discuss later. Okay. So search for Scala ID. Okay, so we're going to download it. Why? Because it has Eclipse with it. Okay, and since we need Scala ID in future, we are going to just make sure that we don't install or download again. Okay, therefore we are just going ahead with this one. Okay, we have downloaded 64-bit, or we could simply click on this one. I think this is the same thing. Yeah. Okay, so those of you who do not have zip installed on their machines, they can use 7zip, which is an open source tool. All right, and this is the one which we have just downloaded. Interesting, it has been downloaded thrice. We're going to just say extract, and unexpected error occurred. Okay, so right, should we download it fourth time? Okay, let me delete all these things which we have downloaded so far, and then try downloading it again. Okay, so although to install Scala, you can actually install Eclipse first and then Scala, but then it is going to be a long path. So what we're going to do is we are going to install, as in download and extract Scala ID, which contains Eclipse in it. Okay, we're just trying to be a little smarter with respect to installations. Okay, let's see if we can extract it. Looks like it's going to take much time. All right. All right, so Eclipse has been extracted. Inside this folder, you can see that there is Eclipse. Just to check if it's running, let's double click and try to see if it's working. Okay, so yes, it is working, and let's just select the default workspace. A workspace is a place where Eclipse keeps all your data, installations, and plugins. So if you are working on kind of different kind of languages, different kind of environments, you can create multiple workspaces. Say you are developing Android applications as well as you're working on some other, say, Python projects or Java projects, then you can create multiple workspaces. Okay, so you can see that we can create simple, we can create Scala project as well as Java projects from here. Okay, we'll see that soon. Okay, now the next step is to check out the code. Let's minimize Eclipse for now. Okay, and check out the code. And on desktop, how will we check out the code? Okay, how will we check out the code? Let me close these windows to make the life a little more easier. Okay, so how will we check out this code from our repository? Okay, this is the repository, right? And we would like to check out this code. This repository is located on Git, in Git, so we can go back to our home. So we need to check out this code, and the URL for us is this. Okay, let's keep it copied. So there are multiple Git clients. There are multiple Git desktop clients for Windows. Out of those, My favorite one is the one that is done by GitHub people. It's called GitHub Desktop. Okay, so you can basically download GitHub Desktop here and okay, so as soon as it finishes, I have run it. I've started it, and so it should install quickly. Yeah. Okay. So it should launch as soon as it finishes. Okay, let's minimize the windows and check if something is happening in the background. We can close some more windows to make our life a little more easier. Okay, so I think it's yet to be installed. Okay, so looks like it has installed. It just did not give us a prompt. Okay, so I can sign into my GitHub account here. Okay, I will just provide my login and password. Okay, let me just log in. And all right. Okay. Now it says that do you want to clone a repository? And I'll just click on yes. Okay. And paste the URL that we have copied from our GitHub repository page. Okay. So this is the URL and here is the folder name. Remember to keep a track of this one. It's basically inside documents, GitHub, and then big data. Okay. This is where the code from GitHub repository is going to be copied. Okay. So this whole step where we have installed GitHub Desktop and cloning it is equivalent of using git clone command in the in the console. Okay, so it is downloading the repository. Okay, so let it download. All right. So once you are done with cloning it, you can go back to Eclipse and browse to the folder where it has checked out. A quicker way to find out where it has checked out is clicking on repository and clicking on show in Explorer inside GitHub Desktop. So you can see that it has opened a browser window showing you the location. Okay, can close it or leave it open. Now inside Eclipse, okay, inside Eclipse or Scala IDE, we go to new and click on project and click on Java project. Okay, and then instead of using default location, we are going to use our folder. Okay, our folder is in the format which is understood by Eclipse. Therefore, it's completely okay to use that one instead of creating a fresh new project. Okay, so I think it is in my documents. There is a GitHub folder and there is big data. Okay, go to the same Java folder in which we ran the ant example. and jar command. Okay, we can give some other project name. For example, we can give mr test. Okay, we have just, or we can just say, okay, let's just say mr examples. Okay, let me go back to the desktop, go back to the Eclipse IDE and finish. Okay, it will prompt you to open Java perspective. That's completely okay to switch to Java perspective. And next is take a look at the code. You can see that all the libraries and source code has come here, right? And all of these are there, correct? Now, at this point, there are multiple things that you can do. One is you can make the changes to the code, okay? And then create jar. And after creating jar, we can transfer the jar to the console. Okay, we are going to do these steps. We're going to first compile our jar or make some modifications to it, and um, then create the jar, upload it to the CloudXLab, and then run it using Hadoop jar. Okay. So first of all, let's make some modification to reflect that this is coming from desktop. Okay. So we are going to go to the driver and just change the output folder to something else. Okay. All right. So here we are. Now let's just call it desktop. So once we run the jar and the output folder java mrout underscore desktop is created in your HDFS home directory, that means that you have successfully run this particular version. Okay. Now we are going to export this. Okay. And we're going to search for jar, and you can see that there is a jar method so there is a jar method. That's the one which we have selected here, the jar, and then click on next and select mr examples. Okay, let everything be this way. Okay, all right, let's just create a program called hdp.jar, or let's just browse to a folder. Let's just browse to a folder, and then let's just browse to say downloads and give a file name, say hdp.jar. Okay. All right. So once we are done with that, we can finish it. Okay. So it is preparing the jar. All right. Let's see what error it's throwing. That's okay. These are just warnings. All right. Now, once that's done, we can check that folder if it is created or not. We can click on download. We can see that this has been created. Great. So now how would we take this to our CloudXLab console? There are two ways to it. One is put it in Hadoop, put it in HDFS using Hive, and second way is using WinScp. Okay, since WinScp is the right way to do it, okay, we are going to use WinScp. All right, let's go back to the browser and install WinScp. So what is WinScp? It's an application that lets you upload file using SSH protocol, or you can say that it's a secure copying from Windows to a Linux machine. Okay. Okay, so how do we download? All right, installation, open the installation program, WinScp download. Okay, and this is the installation package. It should start the download. Yes, it is done. Let it open and then we will install it. Okay. Just go through the installation steps. All right. Let's see. Okay. It has opened the browser window, but let's go back to this. Okay. Now is the important step. We need to copy our, we need to provide the host name of our CloudXlab console so that we can copy data to it. Okay. And we have to provide the username and password. Okay. This host name is same as the host name you see in your CloudXlab console. Okay. For us, it is e.cloudxlab. Okay. e.cloudxlab. So we can just copy only up to e. Okay. Then we paste it here. Okay. Make sure that it does not have HTTP or something. Okay. It should be e.cloudxlab. Now let's get our login password. Okay. So paste the login and then do an alt tab, go back to the same window, do an alt tab, switch to the WinScp and do a control V. Okay. We can also save it so that we don't have to do it again and again. All right. And let me just save it, give it some name. Okay, though we did not select the password to be saved, but that's okay. All right, we need to change that. We need to select the protocol as SCP. Okay, we need to select the protocol as SCP. Okay, save this again. Let me just save the password. All right. When you are prompted with the host key, let it be yes. So this side is e.cloudxlab.com. These are the same folders which would be there if you type ls command, not hadoop ls. This is the local folders of e.cloudxlab. Okay, and you can see that here is the same repository that we have created today. Okay, the one which we cloned it today. Okay, we don't need to touch it right now. Let's upload our jar file. Where was our jar file located? Our jar file was located in the downloads folder. Okay, or there could be another way to deal with it. Another way would be just go to the folder and drag and drop. Probably that should work. Okay, so if I take this and drop it here. Okay, upload hdp.jar to a remote directory. That's right. I dragged and dropped my jar file here. Okay, so if I sort my files based on the time, I should see it. It is displaying folders first, so I might have to go down a bit. Okay, so it has been uploaded here. All right, so we have successfully uploaded our sdp.jar into our e.cloudxlab.com. For me, it is e.cloudxlab. For you, it could be something else. Okay, let's go back to the console e.cloudxlab and then try to run this jar file again. Now this time, instead of using SDP examples, we're going to use SDP jar. Now, since we are in the home folder, we copied it into home folder, we will have to go back to home folder. To go back to the home folder, you can just type cd and press enter. This takes you to the home folder, right? Now, again, let's just try to execute the same Hadoop command. Okay, let me just change the name and the path of this jar file, correct? So sdp.jar is the file which we have just now uploaded. Okay, so if it runs successfully, it should create it should create java mr out underscore desktop in HDFS, right? That's the change we made in Eclipse. Okay, so let's go back to Hive browser. All right. So you can see that the desktop folder has been created, correct? All right, you can see that. There could be a difference in time because of time zones. Now, so we have successfully been able to compile jar using Eclipse and then upload it to the server. Okay. Also, while working in production environment, make sure that in Eclipse, your setting should be that you compile to the lower version of Java. And how do you do that? You can go to the settings. Okay, you can go to the project settings and change the compatibility to a lower version of Java. Why? So that if the production environment has lower version of Java, still your jar should run there. Okay, so you can say Java compiler, and here you can say the compliance level to be lower. Okay, by enabling here, you can say 1.7, for example. Okay, so it's safer to compile things for lower versions. Okay, if you are shipping artifacts. Otherwise, the common way is to ship the source code. Right now we shipped the artifact.jar. That's why it is generally safer to change the compatibility to lower version so that your binaries are able to run on lower version as well as upper version of Java, because upper version of Java can run the compiled code of older version of Java, right? So it's always safer to compile your application to the lowest version possible. Okay. Now we have successfully done uh, two things. One, checked out code on the server and compiled there. Second, checked out code on the desktop, compiled there, and uploaded the jar. Now, since this mechanism where we are compiling the code on desktop, uploading on the server, running it there, right? This whole mechanism is very, very long. Therefore, it does not leave too much space for experimentation, right? The other aspect could have been that we install Hadoop locally on Windows, which is not really possible and it doesn't really make sense. Therefore, let the Hadoop be on the cluster, and on the desktop, what we do is we create test cases, right? So you can take a look at stub test file, right? Here there are some sample test cases, and we can run these test cases on every modification, right? So whenever we make any modification, we will run these test cases. You have to create these test cases. Purposefully, I have left one test case unimplemented. Okay, you can implement the test case. Okay, now there are a few more changes I would like to make. Let's say I would like to have this time two reducers. Okay, and let me just change this. Okay, let me just change this. All right, I've changed this, saved it using Control S. You can also save this here. Now, once we are done making the changes, we can quickly run the test case again if anything is failing. Okay. Okay, except for this one, nothing is failing. This one, if you want to just fix it, we can just comment it out and it should fix. Okay, to launch the test cases, we can run this. Okay, this time everything is passing. All right, so you generally build these test cases really robust, meaning you write down all possible expectations and actual behavior comparisons. So if you take a look at these test cases actually give you uh, a way to test reducer, test mapper, and test mapper reducer together. Okay, once you are done with that, let's say we have made some changes. Now we can push it to the repository from the desktop and then clone the result on our CloudXlab and run it. Okay, let's. So, where are we? We have made some changes on the desktop, run our test cases, and test cases are successful. Now we can go back to we can push this code to the repository and pull it on the server. Okay, so it's like making it available for the QA environment and for the deployment. Okay, so let's go back to the desktop. Okay, let's go back to the Git desktop. Okay, it shows that these are the files that have made that have some modification. We can ignore this one. This is the .class path which is created by Eclipse, and we can also ignore git ignore and also .project. Okay, so these are the modifications we have done so far. Okay, you can see it is showing you exact data. We have removed comments here. We have changed demo to desktop. Okay, and also we can, I would like to make a little bit more changes. Go back to the driver and go down to the place where we have specified the desktop folder. I'm just going to make it _1. Okay, these are just random changes I'm trying to make in order to just test the different scenarios. Okay, now if you see, it is displaying the updated difference. Okay, so we are saying using two reducers. Okay, and different output folder. So this is my comment, and be careful while writing comment. It should be very clear. Okay, I think this expects you to write. Okay, it has done the commit for me. Now we can, once we have done, we can push it to the server. Commit commits the code to a local copy of the repository, as we talked earlier, that Git maintains a local copy of repository, and when we commit, we are committing to local copy, and while pushing, we are pushing the repository to the server. Now let's pull these new changes let's pull these new changes on our console. Okay, on our console. Let's go back to the console. Let's go back to the console and we go to the folder big data. Let me just see. Yes. So there is a folder called big data. You can generally press tab and it'll autocomplete. I'm going to that Java folder. Not required. So let me go back to the home folder first. So this is where our GitHub repository is there. GitHub repository is generally located in a local folder called .git. You see, this is the folder that contains the local copy of Git. It's generally in the top level folder. So git pull is something we can use here. Will basically bring the newer version that we have pushed from the desktop. Okay. Once that's done, let's go to our. You can see that these changes have come here, right? StubDriver, StubTest, etc. So now let's go back to SDP examples and Java and build it again. Okay, using ant.jar. And once you're done, you execute the same command that we did earlier, right? So, all right. So I think next one is this. Okay. So let it execute and finish. Okay. So it has done the work. Now going back to our view, we can see the results. Okay. So here, if I sort the data based on date again, you should see. Do you see that it has created Java mrout underscore desktop underscore one? It contains two files this time. Why? Because we changed the number of reducers to 2. Okay. So both of these contain the result, as in some part has gone here, some part has gone here. And who has decided which one goes where? There is a concept called partitioner inside MapReduce. All right. So this completes our entire exercise. Okay. We started with this, whereby we checked out source code repository on Linux machine. Then we compiled it there, ran it there successfully, took a look at results. Then we checked out the code on our desktop. But for that, we needed JDK, we needed Eclipse IDE, and for that, we needed GitHub Desktop. After we had checked out, we configured the project inside Eclipse and then created an Eclipse project. Created a package. Once that was done, we used WinScp to install and upload this created jar to the server and then run the Hadoop jar command as earlier, just with different um, package name, different jar file name. Next, we made some changes in Eclipse. We did the testing and then we pushed the changes to GitHub. Then we pulled it on the Linux machine. This is the most preferable way of working on Eclipse. Okay, this is how the work in production gets done. All right, you write a lot of test cases, then you start developing, and once your test cases are passing, you commit it to GitHub repository, from where the QA department generally checked out and runs the compiles it, runs it, and tests it. Once they give the go ahead, then you deploy it in the production. All right. So this completes our quick demo on Eclipse end-to-end with MapReduce. Thank you very much. This is Sandeep Giri from CloudX Lab. Stay tuned with CloudX Lab to know more about things and sign up with CloudX Lab to start using and learning new technologies every day.